Alright, so today we're doing binomial expansion, which is basically taking these things on the left and expanding them out. Now normally, well, this is just 1 and this is just a plus b. Normally though, for a plus b squared, you'd have to FOIL that out, and you'd be left with a squared plus ab, plus 2ab plus b squared. And then for a plus b cubed, you'd have to FOIL it out twice. You'd have to, multiply it and then multiply it, and it would be a long thing. So instead, you end up getting this: a cubed plus 3a squared b plus 3ab squared plus b cubed. So there's a very specific pattern that is followed by this. The first thing I want to talk about is Pascal's triangle. So Pascal's triangle starts with a 1 at the top, and then it has 1s going down the sides. So, for example, this has just 1. This is 1 and 1. These are 1 and 1, and to get this middle number, you have to add these two numbers together, so that becomes a 2. Then if I do the next row, these are 1 and 1. 1 plus 2 is 3. 1 plus 2 is 3. Do you guys see how these numbers match up with the coefficients in front of the a's and b's? Alright, and so we can use this pattern to help us out. I'll do one more on here because I forget which ones we have to use. Now I have one all the way out to 10 rows, so like written out. But for today we're going to just do this. So what do you notice comparing this expansion to Pascal's triangle? Again, you should notice that the coefficients expand with the triangle, where this is to the 0 power. Is the first row. And then also you should notice that if you look at a starts at a cubed and goes down a power, so a squared, a nothing. B starts off with nothing, and then b squared, b cubed. So that's how the pattern goes. So now we're going to expand y minus 5 cubed. So if I look at cubed, first, second, third, the numbers are 1, 3, 3, 1. So I'm just going to put those going down to help me out. This is my a value, and this is my b value. So my a value is y, and I'm going to start with that cubed. And then this is going to go down by a power. So that's how you do the a1. And then for negative 5, we start off with a 0, and then we go up a power. All right. So we get these terms. Well, negative 5 to the 0 is, is 1, and we have y cubed. Here we have negative 5 to the first, which is negative 5 times 3, which is negative 15 y squared. Negative 5 squared is 25 times 3 is positive 75 y, and the y goes away. Negative 5 cubed is negative 125. So these are the 4 terms in the expansion of y minus 5 cubed. We did not have to FOIL it all out. Instead, we have y cubed minus 15y squared plus 75y, and then minus 125. So that would be that. Okay, so let's do another one. This one's raised to the 4th, so we look up here. The 4th one is 14641. So I need to multiply these numbers to what I have to do. A is this, B is this. So we start off with 3p to the 4th, and I'm going to keep going and just do this. So it starts off at the 4th and goes down. And then negative 2q starts at 0 and goes up. And then finally negative 2q to the 4th. Alright, so write all those down. Now we have to calculate these. Now be careful, because you do have to raise the numbers to the power. So for example, I need to multiply a 1 times a 3 to the 4th times a negative 2 to the 0. Well, negative 2 to the 0 is 1, so we don't worry about that. 3 to the 4th, though, is 81. Okay, so we have 81 times 1. So we get 81, and then we have p to the 4th. So that's our first term. Here we have to multiply a 3 cubed a negative 2 to the first, and a 4. All those have to be multiplied together. So 3 cubed is 27 times negative 2 and times 4. So we get negative 216. Now we look at what the letters were raised to. P is raised to the third power. Q is raised to the first power. Do you need to put that? No, you can just put Q. Alright, next one. We have a 6, a 3 squared, and a negative 2 squared. Negative 2 squared is 4 times 9 times 6. And when you do 6 times 9 times positive 4, you get 216. That's P squared, Q squared. Now we have a 4, a 3 to the first, and negative 2 cubed. Negative 2 cubed is negative 8 times 3 times 4. We get negative 96, P to the first, Q to the third. And then finally we have nothing. Well, this turns to a 1. That's a 1. We have negative 2 to the fourth, which is a positive 16, Q to the fourth. So my final answer for this problem is 81, P to the fourth, minus 216, P cubed, Q, plus 216, P squared, Q squared, minus 96, PQ cubed. Do I have room over here? I do. And then plus 16Q to the fourth. That is the expansion. Alright, so sometimes I'm not going to ask you for the whole expansion. You guys could pause it, by the way, if you need to see all that. There, you can pause it there. Sometimes I'm going to ask you for the term number or even the coefficient of something. So in this case, I want to know the fourth term if we expand this. So, and it's to the sixth power. So if I go back up to my Pascal's triangle, I don't have a sixth power row. So if I do this, I can do that there. So there's my sixth power row. 1, 6, 15, 20, 15, 6, 1. Now if you look, I want the fourth term. 1, 2, 3. It'll be this term. So you don't have to do all the work. You can just start it here. This is going to be to the sixth. This is going to be to the 0. And then follow the pattern. If this is the sixth, this is fifth, fourth. I want this one. 2x to the third. This is 0, 1, 2, 3. Negative 3y to the third. I want to figure out what this is. That's all you have to do, is figure out what that one is. So you do negative 3 cubed, which is negative 27, times 2 cubed, which is 8, times 20. So you get that this is equal to 4,000, negative 4,320, and then x is being cubed, and y is being cubed. So that would be the fourth term of the expansion. So those are nicer because you do not have to do all the work. You can just expand the one, or just look at the one term. Alright, sorry guys that I was sick doing this. I apologize. It happens. Good luck, and I'll talk to you later.